Okay, I think we should be good to go then. I finally got this to work. Okay, so we're just starting off with the syllabus for those of you that are online for the class. I'll be doing the live streams at the same time that I do the section here in Du Bois. So this is Math 111. This class will be done 2 days a week, Tuesday, Thursday for Du Bois, but for the online section, it's asynchronous. Feel free to watch the live stream recordings or anything along those lines there. There is some information about the class, about the breakdown, where the grade comes from, homework 10%, assignments, which will be done in class 25%, 3 exams throughout the semester at 10% each, 2 projects, one is about halfway through and one's near the end, 15%, and then a course-wide final exam at the end for the remaining 20%. The homework will be done using MyLab through Canvas. Were you able to access that?
Yeah, I got yours.
Okay. I'm glad we were able to figure out the glitch that we had earlier with that. Okay, so there's just more specifics there on any of those assignment types. Homework you can work on as many times as you like. If you submit it past the due date, it's just a 10% deduction if it's late. But other than that, feel free to work on that as you need to. And then there's more general policies and that sort of thing. But I think most of it is pretty self-explanatory. For those of you in the online section, you can actually read all of this on the syllabus tab. It'll outline all of the things that I just went over there. Let's see if there's anything else I need to go over. This one's mainly for the Du Bois section. I don't think it'll happen much this semester, but in case the college needs to cancel, or if I need to cancel for whatever reason, I'll put it in Canvas for you,
Okay.
just so you know. But usually the fall is pretty good that way. Although now that I just said that, we'll probably get 3 feet of snow at some point. Then there's a general schedule on the back. As far as topics that we're going to be discussing in the class. And feel free to just keep up with the assignment due dates in Canvas. Were you able to use the calendar at all?
I think I was able to.
Okay. For those of you that are online, I'll actually share my screen here with you. In Canvas, your dashboard is there, calendar is there. You will be able to keep up with all of the upcoming assignments in the class. For you, the calendar is going to be there. those like red and green things, you can actually click off of those. Just highlight the ones that you need there.
Oh,
Hello.
we're in this class.
Sorry, we got locked out of the morning.
It's all good. It's all good.
Thank you.
You're welcome. Yeah, if that ever happens, though, just feel free to send me a message.
I did email you. I don't know if you got it though. I think I emailed you. I got someone. But we went way over the hospital bunny. That's the one because there's no one here to let us in.
Oh, jeez.
So
That's all good.
we're sorry we're late.
That's no problem. Okay, I'll just hand out some things to you here.
Thank you.
You're welcome. So that's the syllabus for the class. And I'll start handing out some notes here.
Thank you.
You're welcome. Jump to four. I figured I'd just hand it out all at once.
Thank you.
Were you able to see the calendar? Okay, in the meantime, those of you that are in the online section, just let me know if you have any questions. Just so you two know, I also do an online section of this class.
Oh, you do?
Yeah,
Like for the DuBois people or for like Mount Aloysius College? Like the main campus?
for the main campus.
Okay.
But I figured I would just live stream what we do here.
Right.
So, yeah. But YouTube has not been my friend tonight, so. Okay. So, do any of you have any questions about anything I just gave out? Okay. So we'll just get started. Our first chapter is going to be chapter 3. Just going to get this set up here. There we go. A little bit about me too. I'm Mr. Z. I actually teach about 500 yards down the road at Du Bois Central Catholic during the day. And then I do this in the evenings. Yeah.
So you love to teach, I'm assuming?
Oh, yeah. Yeah, I do a lot of high school math and science courses over there, ranging from geometry to calculus. So. All right, chapter 3. Numbers in the real world. And essentially, a lot of the things in this chapter are going to be based on percentages. Just because it's one of those things that most people tend to have mistakes on. People throw around percents all the time, but they don't necessarily use them the right way. So the way that percentages occur, first one would be fractions. So think part of a whole. So example 1/2. Which would be what percent? If so, half as, say, a decimal or a percent. 50%. There we go. So fractions are there. We can deal with them. We can do whatever we need to do with them. Where most of the mistakes occur, though, is when we describe change. So think percent increase or decrease. Try and make that a little bit easier to see. So an example with this. Say we decide to buy a stock. Say I buy a stock for $100. Say something bad happens in the economy, and then very next day it goes to $50. What was the percent change?
Half.
Half. Yep. Started at 100, we go to 50. Over the original. This be a 50% increase or decrease?
Decrease.
Decrease. But where the misconception comes into play here. Now that stock is $50. Say the next day it goes up 50%. What would the new value be?
100.
100?
If it goes up, 50% 50 or 50%?
Yep, 50% of the current value of 50. So it'll be 75 then. And because it's going to be going up half of the amount that this is here. So in other words, this is a 50% increase. From where we were there. But the point being, whenever we're talking about comparing percentages like that, depending on where you start and where you finish, they're not going to have the same results. In this case, which one did the most damage there? The decrease. It's going to take a lot more work for it to get back to where it was originally as a result of the decrease. And that leads to the comparisons. Something like that would be, for example, would you rather have 50% of 100 or 10% of 1,000?
50% of 100.
Okay, so if we have 50% of 100, how much would that be?
50%.
Yep, like in terms of out of the 100 there. You would just have 50 left, right? But if it was 10% of 1,000, how much would that be? 100. So which is the better deal there?
Yeah.
The 10% there. So even though I gave you a bigger percentage there, it didn't necessarily mean you were going to end up with more. The reason being, if it's of a larger amount there, it can lead to differences in the comparison. The only way that you'd be able to directly compare 50% and 10% is if you're dealing with the same amount. So if these were both 100 or both 1,000, then we could do that. Any questions so far? Any questions from those of you online? All right, am I good to erase this up here?
Yeah.
Okay.
I didn't double check. I'm looking.
Yeah.
We're supposed to be filling this out, right?
Yeah, you can. If you want to take your own notes, you can, but
Oh, okay.
the notes I'm doing will follow
Oh.
what I gave you here. Yeah. But usually the best way I've noticed is that if we get to something on here, you can add your own annotations next to it,
Okay.
kind of thing. That's what students have said in the past, seemed to work well for them. So then that gets us to absolute and relative change. For the differences, absolute is going to deal with numbers. Relative is going to be dealing with a percent change. So absolute can be summarized by the general formula new minus old. So in other words, the new value minus the old value. That'll give you the change in absolute terms. Whereas relative it's still going to be new minus old, but then it's also going to be divided by old. In the notes, the old value will also be called the reference value in the notes. But this summarizes what that's talking about there. So dealing with change, we have that. Absolute and relative difference work the same way as this. Absolute difference is going to be compared minus reference. So old is reference, new is compared. But it's still going to be dealing with the same idea of new minus old in order to make the comparison. If the sign here is positive, this means that the new value is bigger than the old value. If it's negative, then that means the old value is bigger than the new value. Any questions about that idea? Okay, the last slide on that first page there. And for those of you online, this can be found in the module section in Canvas, in Chapter 3, PowerPoint notes. Recent data showed that California ranked first among 50 states in average income at about $68,900 per person. And West Virginia ranked last at $46,600 per person. First question, how much lower is average income in West Virginia than in California? So California was 68,900. West Virginia, 46,600. So how much lower is the income in West Virginia?
$22,300.
$22,300. Second question, how much higher is average income in California compared to West Virginia? It'll end up being the same number, except instead of less, it's going to be more. Just because we're dealing with a comparison where the value goes up compared to where it was. West Virginia to California in that case. The first one was California to West Virginia. Any questions? Okay. Good to erase?
Yeah.
Online, good to erase? All right, turning the page, we have P% more than and P% less than. To summarize what that is there,
I have a question. It's
Yeah, what's
gonna be a really dumb question. So
oh,
bear with
what's
me.
up?
So, for the last slide, how did you what was the process of getting, was it the second number? Was it just was there a process, was it just that number? Does that make sense?
Yeah, so for that one, for California compared to West Virginia, it's going to be, the new value is California, which was the 68,900 number, right?
Yeah.
Minus the old value of West Virginia of 46,600. And subtracting those, it would get you to the 22,300 there.
That's all we do.
Yeah.
Oh, okay.
Yeah, the big thing with that, even though we got the same number,
Yeah.
it's just one of them is higher than the other, one of them is lower than the other.
Okay.
Yeah. gonna say, does that help there?
Yeah, yeah.
Okay. Okay, P% more than or less than. Quick example I can give you here. Say we decide to go to dinner somewhere. Anyone have a preference around here?
Red Lobster.
Red Lobster. All right. We go to Red Lobster. And say we decide to go all out for dinner. And say we spend $100 at dinner. Sales tax is typically, you know what it is? Any guesses? It is 6%. In Pennsylvania, at least, 6% sales tax on almost everything you buy. Question here. What would the bill be with tax? How much tax would there be on that bill? $6.
Should be 106.
So $106 with tax. Yep. Now there's a quick way to get here with this. 6% as a decimal would be what?
0.06.
0.06. So if we need to figure out 6% more than the original, all we need to do here, the original value is always going to be 1. If we're dealing with more than, it'll be a plus. If it's less than, it would be minus. Then we're going to add, in this case, the 0.06. So this is whatever the percent is. Adding those up would give us 1.06, right? Take this value and multiply by the original amount. Which in this case is $100. And that will get us to the 106. Any questions on that idea? All right, just to reiterate, say it was 20% more. What number would we have to multiply the original by if it was 20% more? $1.20. Yep. If it was, say, 50% more, 1.50, 1.50. If it was, say, 10% less than the original, if it's going to be less than, this would change to
Negative, minus.
minus. So if it's 10% less, that would be,
0.10.
yeah, that would be this piece of it right there, minus 0.10.
Yeah.
So then if we have 1 minus 0.10, what would that give us? So if we have, it's the one we can rewrite like that, right? Zero minus 0 would be 0. 0 minus 1 we can't do, so say we borrow from here. That becomes 10. 10 minus 1, 9. 0 minus 0, 0. So 10% less would be 0.90 there. What if it was 20% less? 0.80. If it was, say, 60% less, 0.40 there. But that's how this idea works there. Any questions there? Okay. Taking a percentage of a percentage is always risky business. Prime example, say we have 100 again. We take 50% off. That gets us to 50, right? If we take another 50% off from 50, now we're at 25 there. But you're not at 0 after doing that, is the idea. So it can lead to compounding things there. And then it's pretty easy to abuse these percentages there. If you think back to that first example that I had, where you had the stock went down 50% and then went up 50%, what ended up happening with that? So 100 went to 50 after going down that much, right? Yep, so 50% decrease. And then we had a 50% increase from there, which was 75. Yep. But the idea there, same percentage down and up, don't get you back to the same place there. You can't have a decrease of more than 100%. That's just something that you should know there. I don't know how much you all keep up with the news, but a certain somebody said that we were going to be slashing medicine prices by 1,400%. It's not mathematically possible there. Can't have more than 100% decrease. Never average percentages together. So in other words, if you have 6% and 20%, don't try to add them up and divide by 2 to say that it's all going to be 13%. If you have different amounts going on, it may lead to different things. But any questions about anything dealing with percentages? Nope. Okay. Good to erase? Okay, from there, we're going to shift a little bit to putting numbers in perspective. So for this part here, think sizes of numbers. Essentially, are we dealing with big or small numbers? So an example here. Given that there's 300 million people that live in this country, how much do you think we spend on ice cream every year? If we just had to make some estimates here. Or to help you out here, how much do you think you spend on ice cream a year? If you had to guess. Anyone want to throw out a number?
As a whole,
Yeah, say like just yourself,
like 250.
like 200, 250? Okay. We'll go with 200 then. the average person spends on ice cream. And if we have 300 million people, by the way, how many zeros does a million have? 6. So 6 more zeros after this. We have 200 times 300 million. How many zeros in the 200? 2. Let's just tack the zeros on onto the 300 million number. And then all that's left to do here, since we moved them over, 3 times 2. I think I heard it. 3 times 2? Yeah, 6.
That's what I made. I thought you meant plus.
It's all good. It's all good. Then from there, commas after each of the 3 zeros there. So that's how much the US spends on ice cream per year. Which would give us what number there? $60, you say million or billion?
Billion.
Billion. Million is 6 zeros. Billion would be 9 zeros. But keeping the size of the numbers in order will help answer these kinds of questions. So some other problems there that they have. How many people could you employ with $1 billion a year if you were going to pay everybody $100,000? So we have $1 billion divided by $100,000 per person per year. How many zeros could cancel out in both the top and bottom? Yep, 5 zeros. So 5 zeros could go away there. And then we can get rid of 5 zeros there. And then we're left with 1 with 4 zeros. So the point of that example there, if you have a bunch of zeros, they will end up canceling out there. You can work with smaller numbers then. Any questions on that general idea? All right, if we flip the page in the notes. Next part is going to be dealing with uncertainty. And this often comes up in a lot of scientific areas. Any of you ever heard of significant digits? Or you may have heard it called sig figs before. Yeah, significant figures. Chances are you would have seen it if you took anything like chemistry or physics or something along those lines. But essentially, in scientific measurements, where the numbers are significant and where they aren't. So non-zero digits in a number are always significant. So when I say that, things like the 6 and the 1 there are always going to be significant. Zeros that follow a non-zero digit and lie to the right of a decimal point. So think things like this or this. These zeros will be significant if it's after the decimal place in a measurement. Zeros in between non-zero digits. So say something like that. 0 in between the 2 and the 1. That will be significant there. Just because it's acting as a those are situations when zeros are significant. When they're not significant is when you have things like this. Zeros that are to the left of a non-zero digit. So these 3 zeros there are not significant. Or zeros to the right. Say we have 40,000 there for a number. So zeros to the right of a non-zero digit, in this case a 4, but before you get any decimals. These 4 zeros would not be significant. But where it gets tricky is that there are ways where it becomes significant. If you added a period after that, that means all of those become significant. Or if you see something that looks like that, this little bar above the 0, means that everything to the left of it is significant. Everything to the right would not be. So any questions relating to sig figs, as they're called? Okay, how are we all doing at this point? Good. Okay. Good to erase? All right, I think the last thing we'll talk about for tonight is going to be the types of measurement errors. Often shows up in experiments or measurements. Two types of errors that can occur. Random. So you take a measurement, you do an experiment, and it's not what you're expecting it to be. Could be due to a lot of random things happening in that situation. Unable to predict, unable to account for. The other type would be systematic errors. So these kinds of errors are going to lead to issues with all measurements that have some underlying cause. So in other words, this is going to be a situation where all values are too high or too low. Due to some kind of bias or issue going on that's going to lead to those differences in all the values. Hopefully, if there are going to be measurement errors, it's due to random things. Me personally, I'd rather see random than systematic. That's just me. With systematic, that usually means that someone is manipulating the data to some degree in order to get the results to look like that. Any questions about errors? Okay, any of you online, any questions? Okay, I think we'll stop there for tonight. So then on Thursday, we'll pick up right where we left off. And then I think there are a couple of assignments due in campus Thursday night.
This Thursday, you said?
Yeah. But if you run into anything, just feel free to send me a message.
Okay.
Always happy to help. For those of you online, I'll stick around for office hours. I should be here until about 7:30.